Life is full of uncertainties. Should I diversify more in my 401k? Is the Toyota better than the Chevy? How many calories are in this donut? Well, enter random variables. Random variables summarize outcomes of an experiment with numerical values. They can be discrete, or a count, or continuous, where all values in an interval are fair game. All discrete random variables are associated with a probability distribution that provides the probability that the random variable x assumes a specific value, which is illustrated by a lowercase x. And there are two key properties of these random variables that we need to remember. First is that the probability of each value of lowercase x takes some value between 0 and 1, and the sum total of all probabilities equals 1. There are three summary measures that we can use for a discrete random variable: the expected value, also known as the mean, the variance, and the standard deviation. Take note of the equations on the slide. That's how we calculate these summary measures. And I don't know about you, but this stuff makes a whole lot more sense to me when I try it out. So let's try it out. Let's consider the example of a car dealership manager. And for any Adult Swim fans, hopefully you appreciate the meme. So Brad owns a dealership in Chicago. He decides to create an incentive compensation program that equitably and consistently compensates his employees based on performance. He offers an annual bonus of $10,000 for superior performance, $6,000 for good performance, $3,000 for fair performance, and $0 for poor performance. And he expects an employee to perform at superior, good, fair, and poor performance levels with these probabilities. So we want to calculate the expected value of the annual bonus amount. We want to calculate the variance and the standard deviation of the annual bonus amount. And we want to figure out what the total annual amount that Brad can expect to pay in bonuses if he has 25 employees. So here's that table, neatly put together in Excel. So for our expected value, or our mean, we indicate this as with the EX. And what we want to do is multiply the amount of money for the bonus and the probabilities related to the number of employees getting that bonus. So in this case, I want to multiply B2 times C2, and I get 1,500. I'm going to copy that formula and paste it down. Remember, 0 times anything is still 0. And now to get that mean or that expected value, we just sum up our results. So the mean bonus, or the expected value of the bonus, is going to be $4,200. So the next thing we want to figure out is our variance, and I will call this var And to do this, we need to have our mean value, so it's important to calculate the expected value first. And we can calculate this in Excel using a slightly more complicated formula. We're going to use B2, which is the bonus rate. And we are going to subtract from it the expected value. And for this, we use the dollar signs, because when I go ahead and copy this formula down for the other 3 rows, B2 will increase by row. So in the next row down, it'll be B3. But because I locked in D6 using those dollar signs, that will not change as we go down the rows. We want to square this. And then multiply by the probabilities. I'm going to copy this down. And then to get our variance, we just want to sum all these guys together. We find we have a variance of 9.96 million. It's a big number. Now we could also calculate the standard deviation. Do it down here. By taking the square root of our variance. And that's our standard deviation. It's a bit of a smaller number than our variance. So Brad has 25 employees, and our expected value is $4,200. So if he has 25 employees, say employees 25, we would multiply our expected value by 25 to determine how much Brad should probably budget towards bonuses. So we'll call this the bonus budget. I'll just make that a little bit wider so it's easier to see. And our bonus budget is going to be D6 multiplied by E9. Widen this one a little bit, and we find that Brad can expect to pay about $105,000 in bonuses. And depending on the size of the dealership, that could be a little bit of money or that could be a lot of money. Maybe it would motivate him to have more employees that are in the good category as opposed to the superior category. And when we set up a spreadsheet like that, we can reuse it and we can manipulate these things. So say maybe we only allowed 10% to be superior. Saves me over $10,000. Of course, the probabilities have to equal 1, so we have to add that 0.5 somewhere else. So good, maybe 0.3 now. Saves $5,000. Not bad, right? So how exactly you would use this setup varies based on the business application. But when we create spreadsheets like this, it gives us a lot of room to play and manipulate different values to understand the relationship and interplay between said values. So this slide summarizes the work we just did to evaluate the compensation scheme. If you managed a dealership, though, take a moment and think about this approach. Think about it from the perspective as a salesperson, and think about it as from the perspective as the person who owns the dealership. And your thoughts, well, your thoughts may vary, but that's okay. We're not just doing math, we're not just doing statistics. We're using quantitative methods to help us think through real world problems. So every time you do a problem like this, don't just think about the numbers. You want to get the numbers right, but don't just think about the numbers. Think about what they mean. Think about the decisions that you can make based on them. So we're just going to keep on rolling with the car theme. So let's talk about selling tires. Yes, that was a pun. So if you're working with a business and you ask for data from a business, you can expect to get a block of text that will tell you that 50% of customers who go to Discount Tire for tires buy 4, 30% by 2, 18% by fewer than 2, and 5% by 0 tires. So we need to find the probability that a customer will buy 3 tires. So we have our cumulative probability, but that's not really helpful when we're trying to figure out the probability that somebody is going to buy 3 tires. So let's deconstruct our cumulative probability. So now we're just going to look at probability. The probability of 0 tires is still going to be 0.05. However, for the rest of these, we want to subtract the value before it from the cumulative probability to gather the accurate value. So for example, with B3, we would want to subtract B2. So now the probability of buying 1 tire is 13%. I can copy and paste this down the row. And just to make sure, to double check that the probabilities all add up to 1, we can use the sum function, because you remember probabilities all must equal 1. It equals 1. So these are the individual probabilities of buying a certain number of tires. So how can we find the probability that someone will buy 3 tires? We start with what we know. We have the probabilities of buying 4, 2, less than 2, and 0 tires, and we have the cumulative probabilities. So we can use this equation where we subtract from 1 the probability of 4, 2, and less than 2 tires. Or we can deconstruct that cumulative probability, which, I don't know, that worked out pretty well. So here we see the probability of buying 3 tires is 0.02. And if we wanted to look at the probability of less than 2, we would know that it's 18, because in the cumulative probability, 1 tire is 18, but that also includes the probability of buying 0 tires. So the odds of buying fewer than 2 are 18. So the information that we got helped us populate the cumulative probability and a bit of the regular probability table to help us answer a basic question. And given how few people buy 3 tires, you might have some decisions to make about how you market some of your products, or even if you're willing to sell sets of 3. However, products like the slingshots and the The Can-Am trikes. Maybe they can market their tire sales to those types of three-wheeled vehicles. Or maybe owners of vehicles with different size tires on the front and the rear. For example, the Corvette has two different sizes of tires on the front and back. Maybe you could convince a Corvette owner to buy a third as a spare. Although Corvette owners usually aren't too big on spares. You don't buy a Corvette unless you're ready to go in all the way on your tires. So that is a little bit on how we work with random variables and discrete random variables. Check out the text for more examples, and I'll catch you next time.